Hello, thank you for joining me today. My name is Michelle Bauer, and I am a senior chemist in the R&D and Technical Services Lab of ICL Phosphate Specialty, more commonly known as HALOX. Today I'm going to discuss scratch resistance advancements in water-based wood coatings. So let's start off with scratch resistance. This is really considered an unmet need in the industrial wood coatings market, which is the application that I will be focusing on today. This market would consider end-use applications such as wood cabinetry and furniture, also joinery or trim applications, doors, and wood flooring. Now, end users of these types of products really demand high performance and long service life, which includes maintaining the aesthetic appearance of these materials. The coatings industry continues to move from solvent-based products to water, so there's always some formulation challenges that must be overcome when making that switch. And scratch resistance is certainly one of those properties that must be maintained. Now, when I say that's an unmet need, it's not that it is not currently being addressed in the market. There are many additives and resins that tout scratch resistance, but what I'm referring to is the peak of that performance has not been satisfied yet. There are further advancements that can take place in scratch resistance that is currently not being achieved. And when thinking about long-term service life, of course you think about the abuse that these types of materials go through in homes, such as pets or kids that are going to cause scratches to these cabinetry and furniture, for example. But also think about the installers of these types of materials. They go through much care in the installation of these products, and if a product became scratched during installation, that would be a very frustrating situation for them. So taking a step back to think about scratch resistance, what does it exactly mean to you? Unfortunately, there are many definitions of scratch resistance, and there's really no agreed upon standardized test method at this point. When taking a step back even further, scratch resistance can be put into the family of performance properties considered coating hardness. And looking at the paints and coating testing manual, there's actually over 30 types of equipment that have been developed over the years, all aimed at trying to determine or measure the hardness of a film. Some of these more popular equipment is listed here, which many of you may use or recognize, including the Hoffman scratch tester. Tabor abrasion is very popular. Other things like the balance beam tester or the Martindale are all equipment that can be used that some people consider to be a scratch test. And when breaking that film hardness measurement down, I really think it can be divided into three unique characteristics. You can be looking at the wear of the film, how much it is resistant to abrasion, which I think very much lines up with Tabor abrasion resistance. And that is the testing that we've used that I'll demonstrate today. You can also be looking at the ability of the film to resist penetration or lose adhesion to the wood substrate. In this case, I equated that to pencil hardness test. And then the final one, which is our main focus today, is the ability to resist scratch or surface deformation. And in our case, we have chosen steel wool double rubs as the method of measuring that key property. So when looking at the additives that are currently available on the market today, there are a variety of chemistries that are offered, and some of them have um, benefits but also significant drawbacks in their use and formulation. One of those, which stands out to me, is the many types of wax variations that can be used, including a straight polyethylene or low or high density versions of them, and then also PTFE variations. Other chemistries that we have found in this landscape are more mineral based, so aluminum oxides or silicate dispersion material, and then also like colloidal silicas you'll see as a scratch resistance additive. But drawbacks can come with all of those chemistries. Waxes can create adhesion problems when using multiple coats, and they can have bring more difficult dispersions and also possible surface defects. Aluminum oxides and other silicate materials have high hardness values when looking at the Mohs hardness scale, but they can often come with high density, so it's difficult to maintain them at the surface of the coating. ICL has developed a new product in the arena of scratch resistance called the NSSD, or Nano Stabilized Silicate Dispersion. This chemistry is unique to the scratch additive market and really demonstrates improved performance versus other current market offerings. So I have some animation on the slide to really demonstrate some of the current chemistries that are used and how the NSSD is different. Keep in mind that in order for a scratch resistant additive to be effective, it really must be available at the surface of the coating. So to start off with, we'll view how a wax performs. A wax must migrate to the surface of the film in order to be effective in preventing scratch resistance. So the density of that wax and the coating itself must be taken into account in order to formulate this migration into the product. Now over time, as it's subjected to scratch or other abrasion, it's common that waxes will wear away from the film, really preventing long-term benefits and only giving a short-term improvement in scratch. When looking at a mineral with a high hardness level, those products also come with high density. So while this product may be dispersed throughout the coating, it is difficult to maintain it at that level of the film as it's curing. It will often not remain in an area that is providing a benefit for scratch resistance. The difference with the NSSD is it has this nano component that's specifically designed to stabilize a silicate material at the surface of the coating. So it remains available to prevent scratch, and it also is well dispersed throughout the film. This is a unique property that you'll find with the NSSD and really provides a big advantage in the scratch resistance of a coating. So I'm going to walk you through a series of test results that we have performed in our lab, and we are comparing the NSSD to a variety of scratch resistant additives that are currently on the market. So this is a list of all the performance testing that was completed on these additives in a cabinetry type application. And these tests were really chosen based on guidance from the KCMA specification and also the Woodwork Institute standards. This is the screening formulation that was used to test all of the additives. The target application is water-based UV curable urethane acrylate formulation. And this resin system is specifically designed for wood applications and even more specifically for high gloss transparent films. So this is a simple formulation. It has just a few additives to it in addition to the resin, and you'll see that the water-based UV formula requires a three-step drying process, which is listed here, and the formulation properties are also available. This is a table that lists all of the additives that were evaluated in this study. You'll see here that we have duplicated the chemistries available that we reviewed earlier, so that there are a multiple variations of wax in the study, also a nano aluminum oxide dispersion, and a nano silica, and a colloidal silica. Now for each of these products, we reviewed the manufacturer's suggested loading level and completed a ladder study on each of them separately. So multiple points of use was measured so that each product could demonstrate their best scratch resistance capabilities. Once we determined that optimized level for scratch, that was the level that was used throughout all of the testing. So the first of all of the tests that I want to review is, of course, scratch resistance, because that is the most important for the study. This is just a demonstration of the ladder studies that were utilized for each of the additives. So here you can see that for the PTFE, for example, the 3 points that were run, it was actually found that the mid-range was the optimal level. On other example, the HDPE that was run, it was actually the lower level that provided improved scratch more than the higher level. So again, it points to the benefits of running a ladder study with any additive evaluation. For the NSSD in particular, we ran a wider range of performance ladder, and in this case the optimal level was found to be at 6%. There is quite a significant improvement even with a 2% level, but again, we chose the highest level scratch performance that could be achieved for each of the additives. So now let's review the scratch resistance for all of the additives combined. Again, just to refresh your memory, we used steel wool double rubs as our key property, and we measure that actually in 3 different levels of double rubs, just to provide a broader view of performance depending on what level of performance you're looking for in each lab. So 50 double rubs probably indicates, the failure point for many formulations, depending on the resin system. So in this case, you can probably pretty starkly see that the white bar of the NSSD provides a significant improvement versus any of the other additives. And this is a measurement of a change in gloss over before and after each of these cycles. So the NSSD again stands out versus any of the other chemistries in providing significantly more, actually over 6 times more effective than the average of the rest of the products. The other properties, again, that we're going to be used to measure film hardness, in addition to scratch, are pencil hardness and Tabor abrasion resistance. In the pencil hardness test, again, the NSSD stands out as a significant improvement over the blank control. Other additives see no or very minimal change to the pencil hardness test. In looking at the Tabor abrasion results, measurements were taken at both 500 and 1,000 cycles when using the more severe CS17 wheels. In this case, when looking at the 1,000 cycles, most of the products provided no change to the Tabor abrasion resistance. You can see a slight improvement with the HDPE, the NaOD, and the NCS products. But overall, I would say that this resin really provides excellent Tabor abrasion, and these additives did not provide a benefit or a detriment in this case. But remember, the target that we're looking for is scratch resistance, and each of these hardness measurements really can give you a different view of the hardness of that film. Moving on to gloss development. When you're trying to develop a high gloss product, of course you want to maintain the gloss as high as possible within that range. So in this case, many of the additives maintained the product within a high gloss category, including the NSSD. Some of the other wax additives, such as the PTFE and the PEW, had more of a significant change in the 20, 60, and 85 degree measurements. Coating clarity was also reviewed in 2 different ways. One was just a visual assessment. So all of the Halox logos you see there are actually topped with a piece of glass that has a film drawn down over it using each of the additives. Pretty much all of the additives perform very well here visually. The exception would be the PEW, which even here shows a pretty significant hazing of the image. Of course, it's difficult to replicate these visual results to a slide, but I can also tell you that there was a slight haze on the PTFE, and the remaining products all looked very similar to the blank control. These results can also be duplicated when looking at the 20 degree gloss. So again here, the PEW had a significant drop in 20 degree gloss, and there was also pretty significant change with the PTFE. When looking at chemical resistance, we chose some common household stains or materials that you would find in a kitchen and measured them after 24 hours of exposure under a watch glass. The exception, of course, would be mustard, which is a very severe stain, and that test only had a 1 hour duration. I like looking at these results in a cumulative manner, so when you look at the total scores here, you can see overall there is little change to the chemical resistance versus the blank control. The biggest detriment here can be seen with the PEW, and again, I think that lends to the lower gloss that was found with that product. probably making the film more porous. All of the other products are, only a point or two away from the control. The results were also reviewed after a recovery period of 24 hours. And so all of the cells that are highlighted in green showed an improvement in their rating after that time. So in this case, there are a few products that actually showed improved results versus the blank control after this recovery period, namely the NSD, which is the nanosilica dispersion, and the PTFE and the PEW. The rest of the products have the same rating as the blank, including the NSSD. Water resistance was measured in two different manners. One of them was the spot test that you just saw previously on the chemical resistance, and I just wanted to highlight it because it actually was a bit surprising to me that many of the additives actually showed a slight detriment, or I wouldn't say detriment, but a slight lower level rating than the blank control. Keep in mind that the difference between a 5 and a 4 in my scale is 5 is no effect, 4 is just a very slight ring that is visible basically at the border of the watch glass. So many of the additives provided a rating of 4 in that test, which caused me to try to want to investigate further into the water resistance and try to find more differentiation between all of the additives. So I put it through a much more strenuous test in a water immersion. And what that test was actually applying a film over glass and then immersing it in, it would go through the complete drying process, the 3-stage drying process, including the UV. And then after 24 hours of cure, it went through the water immersion test of actually putting the glass plate into a ambient water bath. And observations were taken at a 4-hour and 24-hour time frame. You can see here that obviously this resin system is not designed for glass adhesion, but there are differences between all of the additives in terms of level of blushing or wrinkling of the film. The thing that I key on is how that film recovers after another 24-hour period. And in this case, there were 4 products that were able to recover to the fully no defects in their film. That included the blank control, the NSSD, the PTFE, and the PEW. I think that's really the key that you're looking for when trying to resist any water stains, that you could achieve on furniture when placing a glass on the surface. The final 2 tests that were reviewed were adhesion and cold crack resistance. Adhesion, of course, is important in all coating types, and here it was measured in a few different ways, again, to try to determine differentiation between the samples. Wood adhesion was easy to achieve for all of the products, all of the coatings, so a 5B rating was found. Interestingly, intercoat adhesion on those substrates were seen as failures for some of the additives, so I think that again points to some of the drawbacks with formulating with waxes at time. So the PTFE and HDPE saw a significant loss of adhesion when looking at intercoat. And many of these wood coating applications require multiple coats. Often 3 to 4 coats of these UV products are applied on a finished product. And then to further create a more strenuous test, adhesion over glass was measured. And here again you can see the difficulty of adhering to glass, but also differentiation between the products. The PEW was the only product that really had a good rating. Again, I think that leads to the lower gloss of the film. But the NSD and the PTFE also had better results than the blank control. So when looking at the products overall over these 3 situations, the NSSD actually stands out as the product, in my mind, that provides the best adhesion results. Ignoring the PEW in this case because of the significantly lower gloss, I think that's really a different formulation. You're not comparing apples to apples here. Now switching over to cold crack resistance, this is really just a cyclic test of extreme temperature changes. So you go from a 1-hour test at -10°C immediately to a 1-hour exposure of 66 degrees C or 150 F. And that cycle continued for eight cycles, and in this case none of the additives presented any failures after that 8 cycles. So it really demonstrates that these scratch resistant additives have no effect on performance in this property. So combining all the tests into one spider diagram really gives you a good visual display of how all the additives impact performance. In some cases, the performance was very similar between all of the additives, and these tests could be seen in such as Tabor abrasion resistance, chemical resistance, and of course cold crack resistance, where all of the coatings passed. But really the areas that we're looking for is where is their differentiation, and that can be found in, of course, the gloss, pencil hardness, adhesion, and the property of focus, scratch resistance. The NSSD really stood out as providing the best balance of properties, in addition to having superior scratch and pencil hardness over the competition. I think this is really a rare case where an additive provides a good balance of properties, and you're not trying to improve one property while deterring away from another. So it provides you the ability to formulate specific to your customer's specification. So I want to thank you for your attention during this presentation. I hope you found it informative, and I encourage you to reach out to Halox at our website, where you can contact our technical service team. You can also reach out to me directly if you have specific questions about anything you saw today. I'd like to thank the Cleveland Coating Society for still moving forward with the Sink or Swim virtual symposium. I think it's great that we can continue to facilitate knowledge sharing throughout the industry to keep us moving forward in these difficult times. Again, thank you and take care.